Hello students, welcome back to the lecture series on discrete mathematics. We are learning techniques of counting and this is video part 3. In this video we are going to learn the permutation and combinations. Let us see the definition first and then we will go to the explanation. Permutation. A permutation of a set of distinct objects is an ordered arrangement of these objects. The word ordered is very important here. The R permutation. An R permutation of n distinct objects is an arrangement using R of the n objects. That means we have total n number of objects and we are talking about only arrangement of R out of the total number n. Number of R permutations of a set with n elements is denoted by PNR or NPR. Now the R combination. An R combination of n distinct objects is an unordered selection of R objects from the set of n objects. Here we are talking about the unordered selection of n distinct objects. Number of R combinations of a set with n distinct elements is denoted by CNR or NCR. The notation is given here. Let us go to the explanation. Theorem 1 states that if n is a positive integer with 1 less equal r less equal n, that means out of the total n objects we are going to select r, then PNR is equal to, that means the selection or the choice for the first position we have n number of choices, for the second position we have n minus 1 and so on. Here you can consider an example where if you want to arrange the number of students for a photograph and if there are 10 students, so for the first chair or the first position you have 10 choices for the students. For the next you have remaining 9 choices, remaining 9 students, and the rest of the students we have 8, 7, and for the last chair you just have one option left with you, that is the last student. So that is in the form of factorial can be written as PNR equal to n factorial upon n minus r factorial. And if you are arranging all of them, so that will be PNN, means total n number of objects to be selected and the arrange. So that is done in n factorial number of ways. So the example 1 is, how many words of 3 distinct letters can be formed from the letters of the word many? First of all, we should be able to understand what we have as total number of objects. So we have to form 3 distinct letter word from the letters of many, M-A-N-Y. So we have total 4 letters of the word. Out of those 4, we have to arrange only 3. So this is an example of a permutation since order is important. So this is P43. So the answer will be 4 factorial upon 4 minus 3 factorial. So it is 24 3 distinct letters can be formed from the letters of the word many. Permutation examples, few more are there. In the example 1, arranging 3 books on a shelf. So if you want to arrange 3 books, of course the books are distinct. We are not talking about the same book or the same subject book. There are 3 distinct books and we want to arrange it on a shelf. So it is like first, second and third. So it can be done in 3 factorial ways, because from left or from the right if you start. So from the left there is a choice of selecting 1 book out of 3. For the second position we have 2 choices and the third position we have 1 choice left. So it can be done in 3 factorial ways. So total 6 permutations are possible for 3 books. In the example number 2, choosing a 4-digit pin, and it can be done in 10 raised to 4 ways. So a 4-digit pin from left or from a right, So first position will be having 10 choices. Means out of the digits 0, 1, 2, 3 up to 9, these are the 10 number of digits. So first position we have 10 choices. For the second position, since the repetition of digits is allowed, so we have for the second position also, we have 10 choices. For the third position of the pin, again we have 10 choices, and for the last one also 10 choices. So it is 10 into 10 into 10, that is 10 raised to 4. So choosing a 4-digit pin, we have 10 raised to 4 number of ways of doing this. Now the combination examples are selecting 2 books from 5. Selecting 2 books from 5 means any 2 books. So here we are not talking about the order in which the books are selected. Out of any 5 we are choosing any 2. So it can be done in 5C2 ways. Here also you should be able to understand the difference between the permutation and the combination, and we should be able to understand whether this is selection example or arrangement example. So whenever it is selection and the order is not important, it is unordered, we are going to use the combination formula C52. So it is 10 number of ways. In the example number 2, choosing 3 flavors from 6. So it can be done in 4C2 ways. So either of the flavor we are choosing. So out of 4, the combination will be, it is 4C3 actually. It can be done in 4C3 ways. So this is an example of combination. Now there are one more theorem to discuss and the important formula. The number of R combinations of a set with n elements, where n is a non-negative integer, is n factorial upon R factorial into n minus R factorial. The important formula, we can always use the formula. The first one is NPR, which we have already seen, n factorial upon n minus R factorial. NPN means arranging n objects and the total objects are also n. So that is like n factorial. NCR means choosing R objects out of n or selecting R objects out of n objects. That is NCR. NCR is also, if you see the 4th number point, you can also say that choosing R number of elements out of n. This also means choosing n minus n elements for the rejection. That means if there are 10 students, if you want to choose 7 students, you may decide that which students you do not want, means the rejection criteria. So you may decide that out of 10, 7 if you want, 10 minus 7, that means you have to reject the 3 students. So NCR is always equal to NCN minus R. So you may think about the rejection, means choosing is one thing and rejection is another thing, but we are doing the same thing there. NCR is equal to NCN minus R. NC1 means if there are n number of objects, distinct objects, and if you are choosing just one, so that means it can be done in n number of ways. NC0, that means if you are choosing nothing, so this can be done in one way, you are choosing nothing. NCN, if there are n distinct objects and if you want to choose all of them, that could be done in only one way. And NCN minus 1 means if you want to choose n minus 1 elements, that means you want to reject just one. So you are talking about either you can reject the first one, second one, third one, or nth one. So there is n number of ways to do that. So this is the permutation and the combination. I hope you understood. Thank you.